Hello, Ernest.
Hi, how are you?
Good. How are you doing?
Good.
Hi, Anthony. We'll start shortly, so just check out the lab. Let me get my REPL up. Hi, Chris. How are you doing?
Hi, Professor.
I hope you're doing good. Let me pull up the lab here. Let me double check to see if you guys have the right file. Yep. Okay, good. Okay, hi everyone. I hope you're doing well. We're wrapping up week 4. 12 more weeks to go. Check out the lab for today. And we're going to do some exercises in C++. So you can also open your Visual Studio or REPL or whatever tool that you want to use to program. Let me find and make sure my microphone. Okay. All right, so I'm going to go ahead and get started. Let me make sure I'll share screen. So we are going to do permutation in C++ today. And I included some tutorial from YouTube. He talks about how it permutate there if you wanted to get a little bit further about, how to really use permutation in programming. But we're going to do this lab today where we're going to touch on how some of the functions that's built into the STL, how we can use it to permutate through a container that would contain different elements that would have either numbers or letters and so on. Okay. So here is our lab. And in this week, we are going to use Algorithm STL, and you will see this quite a bit until the end. This is going to be one of the library that we can commonly use when we implement an equation. Or in our case today, we are going to use some of the functions that is in the Algorithm STL. Okay. And to start, it talks about how next permutation is a lexicographic function that rearranges the elements, which are numbers, in your container. And so that way you would have different combinations of those elements display. So in the case where if it's not able to set up the arrangement of the group of elements, it normally would start with how it would go from the lowest possible order. In our case, that will be ascending order. And when we're using integers like 1, 2, 3, 4, 5, you would see that it's going to go from low to high, meaning small number to large number. And so what it will do is it's going to give you the arrangement. So the example that's shown here is that when you have the inputs, which are the element values, on the left column, so this one we would have 1, 2, 3, and it's going to output 1, 3, 2. And you notice that it's going to shift the arrangement of the values, and it's going to give you the output. So it automatically would do that when you implement this function. Now, what it will do is it's going to take that output and then it will continue to shift the value. So then you would eventually have a different set of values that will be represented as combinations. So how does it know what would be different? It would look at the comparison of the value. So when you look up the term lexicographical comparison, all that is that it's going to use the sequential value in the container, and it's going to look at each of those values. So that way it's going to compare one with the next. Therefore, it's called next permutation. Now, it has to make sure that the elements are not equivalent to one another in the comparison, so that way there will be no matching element. So you will never have an output that would have a repeating value like 111 or 222 and so on. So when we look at the permutation and how it is, if we're using character like GFG, it would be GGF, and for the next permutation, where your next letter would be different. And so when it output that, and it's going to shift it again, so that way you would see that your combination will be different than the past. Now, when you look at permutation, you have to know that order does matter, right? 1, 2, 3 is different than 1, 3, 2 is different than 3, 2, 1, and so on. So the order, how it present you with the output, the element order makes a difference, okay? Even though we are reusing the values, however, the order matters in this case. So therefore it is a permutation. So in C++ algorithm, this function called next permutation, it is used to reorder the elements in a certain range, where it's going to look at the next greater permutation. So your outcome would be specific and it will be greater than the one that was previously arranged. So then we would have a factorial of n, and when n is going to be the number of elements in the range. So if you have 5 elements, that will be factorial of 5, and then that will be 5 times 4 times 3 times 2 times 1. That will be the total number of arrangements that we are going to get out of that set of elements. And it's going to start with the begin. So in the next permutation, you want the first element. So let's say I have 1, 2, 3, 4, 5. My first index is going to be 0, which is number 1 initialized. Then it's going to use those values based on the sequential index to make the arrangement by the comparison, in which your object, when it rearranged, it will be larger than the previous. Okay, so when you look at the example above here, if you have 1, 2, 3 to start, the next arrangement is going to be 1, 3, 2, in which the output is larger than the previous arrangement. Okay, so when does it end? Is it going to go on forever? No, because it's designed to only going to give us the n factorial, And when it stops is when it reaches the false condition in that it can no longer give us the arrangement that will be greater than the previous. Okay. So when we start, you're going to see that we're going to go from low and then we're going to end up with the high value, right? So if you start with 1, 2, 3, you're going to end up with 3, 2, 1 at the end because it has to be the largest value that's going to finish out where it cannot find any greater arrangement to give you in which it reaches the false condition and it will stop. So now here it tells you a little bit more about the actual function itself. And it says that the first such sorted possible permutation, one would compare lexicographically smaller than all the other permutations. So you know that when you start, because it's designed to go from ascending, your beginning combinations or your arrangement is going to be the lowest, and in which the elements are sorted in ascending order. The largest has its elements sorted in the descending order. So you always going to have n factorial as the total number of possible arrangement of all your elements at the end of your function. Okay, so if you have 20 elements, then it will be 20 factorial, and it's going to give you the number of arrangements based on that. And that was incorporated with how they wrote the function. And it says here that if the function can determine the next higher permutation, it rearranges the element as such that it returns true. So it's going to keep going to give you the higher arrangement until it can no longer, and that will be the end of our permutation. That will be the n factorial. So the example that you see here, okay, let me pull up my REPL real quick. And we are in 4. So we're going to look at this program line by line so you can understand. And there are comments, so you can use that to refer to what each line does or each section. We're not doing anything special in this like all the other program we looked at. Everything is built into the main. At the top, you are going to have IO stream for C in and C out for input and output. We want to display something on screen, so we have to have that. You would have algorithm because that's the library that we're going to use as we are going to utilize the function that was written for that library. And if you want, you can do using namespace std, or you can type that out as you go. In the main function, we initialize the array. I just want to make sure that you have, so let me fix the value here as I didn't change it. So we initialize the value for our array, and we have a 4-element array, 1, 2, 3, 4, right? Same as yours. And we want to first sort our array. And when you're using these built-in function from a library, you have to make sure that you look at what they require. So how it's going to compare is that we want to make sure that no matter what order it's in, we have to pre-sort it. So we would then sort the array. And when you do the sort function, you simply pass the array name, which contains your initialized values. And then you want to sort the number of elements inside that array. So that will be 4. And we want to display some kind of outcome. So we want to put some text to show what it means. And this one, it has a do while loop. So for our index, we're going to start with 1. And we're going to have a do. So it's going to see out, right? Your I is going to be starting with index 0. That's the first element. Then index 1, index 2, index 3. So as we have 4 elements, it's going to go from 0 to 3. Now, can you do a for loop for this? You sure can, right? All we're doing is just to iterate through it, but this is a way that we can write it with a do while. And we want to update, and as it goes through and loop, we want to, we have an increment every time. So the permutations is going to stop when the array is in the descending order. So we're going to go from low to high. So we're going to start with the arrangement that's going to be low. We're going to end up with the higher arrangement. So with that, we have to put in a while condition that needs to exit, right? We don't want an infinite loop. So we would have while, right? And then here is our function. Next, permutations, and we want to permutate through our container, our array. So just like the sort before, we would pass for our argument, that will be the array and the 4 elements in that array. So what it's showing you is this is your array to start, and then after it runs through the permutation, it's going to give you the outcome, right? And so we want to display again the elements after it rearranged. Okay, very simple. And then we have a return 0, and that concludes our program. So when we run this, okay, now you would see that we had this display because there are 4 elements. So it's a factorial of 4, right? That means that we take 4 times 3 times 2 times 1, which gives us 24. Then we would start with the initial as we sort it. Okay, so no matter what number you throw in here, if you execute the sort function here, it's gonna sort and start with the sort. So as you look through each of the iteration, you notice that when we start with the low arrangement, 1, 2, 3, 4, because we sorted. Then when it runs through and it does the next permutation, it's going to compare, it's going to look at how it's going to arrange this. That's going to give you a larger value each time. And there's not necessarily a position in arrangement. It's actually having to look at the value, right, of the arrangement itself for those group of numbers compared to the previous. Okay, so then you would have 1, 2, 4, 3, which is larger than the previous. Then the next one is 1, 3, 2, 4, right, which is larger than the number 2, and so on. So by the end, you completely go through 24 iteration of arrangement, and you would end up with 4, 3, 2, 1, which is descending order from high to low. So we go from low to high, and by the time that it finished arranging it, it's going to give you 4, 3, 2, 1. So my student would tell me, well, why do we need to learn this, right? Since we talked about the mathematical calculation, you do see the implementation of the function in the programming. And in the case where you have to write a program to be able to give you different combination of a certain value, you can definitely use the library and call its function and be able to execute something like this. Okay. And you would have completely different arrangement of numbers or objects every single time, because order matters in permutation, right? The first is different than the second, different than the third, and so on. And then after loop, right? When it exit, we end it, there's no more, so we come back to the beginning. Okay. Is this really necessary? No, but it's just a way that we wanted to see where we start and where we end up with, and after that, it comes back to the beginning. Do you have any question for me? And you don't have to add in all the comments. The comments, if you do include it, so if you're confused, you can always go back and look at it and see what it means to be writing that certain line. Okay, so as you enter that example in your IDE, okay, you would use that example and you can create a program with 4 elements like what the example shows. You don't have to use the exact one. You can see how that works. And we want to start with the calculation. So with discrete, why are we really teaching the math with the programming, right? Because the way that you implement algorithm, you have to prepare and design your program, right? Especially when you're doing something like this, where you want to display based on, what you intend for the program to do. You have to keep in mind that, you want to calculate it first and see if the program is going to achieve your goal. The program is only accurate as its programmer. Okay. So when you approach something like this, you have to have a mindset of, okay, how many arrangements am I going to have? This is a permutation. So if I use 4 elements, I should have 24 arrangements. Now, if you're using a function and somewhere in between you did something, and if it's not giving you 24 arrangements, then you need to go back and fix the program. Okay. So we would then start with the calculation. Since we have 4 elements, we would do a factorial of 4. All that means is we would take 4 times 3 times 2 times 1, and that would give us 24. Then when we run the program, we would take a screen capture and make sure that you describe the elements, how it arranged each loop, right? Like as I explained earlier, what is different in the second outcome compared to the first, or the third arrangement compared to the second, and so on? What is changing? How is it compared? Is it greater or less than, right? So give me like a couple sentences there and give me a screenshot. So later on, when you go back and look at your lab, when you're doing your project, you can reference it. You can say, oh, I remember doing this function. I can definitely use it for my project. So all I have to do is to include that library and then be able to write the function that will call on that built-in function from that library. Okay, so provide an explanation or a description of how your program outcomes would be as far as the arrangement using next permutation. And we're going to use quite a few of these different ones so you can see. And then for part C, I want you to replace the first element and the second element with a higher value than the rest. So if you look at the example here, right, like if my original array, I started with 11, 12, 13, 14, for example, I want to make the first 2 value higher. because we wanted to see if, so when you look at the content of your code, you should know that there is a sort function. So no matter what values you put in the initialization, it should sort it and then it starts there. Okay. So I'm going to try C now so you can see. So let's say I put 21, 22, and 3 and 4. Okay. And then I will run it. So as we force it to sort here, it's always gonna go from low to high, right? So I have 3, 4, 21, 22, 3, 4, 22, 21. That's larger than the previous. And then 3, 21, 4, 22, and so on. And then by the end, I have the largest number first, and it's gonna go descending in the last round. And since I'm using 4 numbers, 4 integers, I would have n factorial, which still gives me 24. Question. So for C, we simply replace it with the higher values for the first 2. And then we would describe the outcome. What are the main differences? Should just only be your values. It's still going to do the same thing that it did in the other one, right? So when you replace the value, it's still going to sort it from low to high, and then it's going to do the comparison for each of the arrangement. Each time it's going to be larger, and then take a screen capture. So with this exercise, we are introduced to next permutation function using algorithm STL. And we want to examine and observe the behavior of the function as it's written in the program using 4 elements. And we understand that permutation for 4 elements is going to give us 24 arrangements as an outcome. And order does matter. Okay, make sure we do a screen capture for C and put in a couple sentences describing the outcome of your permutations after you modified the numbers. So let me put this back so I don't forget. Any question? Okay. So for 1, we just have to complete calculation, run the program, describe it, take a screen capture, change the numbers, run it, describe the outcome, and then take another screen capture. So now we're going to look at going the other way. right? So you saw how next permutation works. Every subsequent arrangement is always larger than the previous. When you use previous permutation from algorithm STL, it's the other way. So the arrangement of your object is going to be smaller as arrangement compared to the prior. Okay. So it rearranges the element as such to returns true when it does the comparison. So it's going to be smaller than the prior. So that means that we are going to rearrange the element in the descending order. Earlier we go from low to high, now we're going to go from high to low. And since it's permutation, we're still going to have the number of input, and we put that through factorial. So if you have 100 elements, that will be 100 factorial. If you have 5 elements, that'll be 5 factorial. That will be the total number of possible arrangement for your permutation. So when it reached the end, right, it would stop because then it would no longer be true. So the last paragraph here, it says that the first such sorted possible permutation, the one that would compare lexicographically smaller to all the permutation, is the one which has all its elements sorted in ascending order, right? We're going to end up with low to high. And the largest has all the arrangements sorted in the descending order. Okay. So example 2 is similar to the first example, but in this one, we are going to use a different permutation. We are going to use previous permutation. So the only changes that you see from, right, the previous program to this program is 2 areas. Number 1, you are going to do a reverse sort. So you sort and you reverse it. Then the second area is going to be your function is different for permutation. You're going to do the previous permutation compared to the last one. Okay, so you have to start with a sort that is going to be high to low. Remember earlier when we do a regular sort, it's low to high, but now we're going the opposite way. We have to do a reverse sort. So we sort it and then we use the reverse function to switch it for descending. And then we are going to use previous permutation to make sure that it gives us the arrangement that's subsequently smaller. So it's going to go largest and then next largest and so on until it reaches the end. That will be the smallest arrangement that you're going to have. Okay, so previous permutation. Let me fix the number here. So same as the last one, we have IO stream. We include the library or STL, that will be your algorithm. We have a main function. Inside it, we declare our array and we initialize it with 4 elements with the value of integers 1, 2, 3, and 4. Then we are going to use a sort function and we're going to sort the array and its 4 elements. After that, we are going to reverse the outcome of the sort for the array and its 4 elements. So no matter what you initialize in here, these 2 are going to give you a descending array. the values from high to low. Then same as the other one, we have a do while loop. We would first print out the outcome from the reverse sort. Then for the while loop, we want to use the previous permutation and our array to give us the arrangements that will be high to low. So all the subsequent arrangement will be lower from the previous. So let's run this. And so I start with 4, 3, 2, 1 because I reverse sorted. Then it's the second round, it's going to give me 4, 3, 1, 2, which is less than 4, 3, 2, 1. And then also subsequently in round 3, I see that 4, 2, 3, 1, which is less than the prior, and so on. And then eventually you have the 3, and then the 2, and then the 1. So it's going to end up with 1, 2, 3, 4. Okay. Any question on this program? So we want to refer to example 2. We're going to put that in our IDE, but first let's calculate just like the last one, right? 2A calls for calculation. So we know that there are 4 elements in the array. Rn is going to be 4. That's the number of your input. And we would do an n factorial, which is 4 factorial, which also gives us 24. So you take 4 times 3 times 2 times 1, that will be 24. Then for part B, for number 2, we would run the program and then we observe the arrangement and we would describe how it is for each of the iteration compared to the prior. And how is it different than the program in example 1, right? So describe the difference there. And then you are going to take a screen capture of your program. So then we are going to replace the first 3 elements as larger. You can do 2. So I want you to just change the first few elements and see how that would be. So if I start with 10, 11, 12, 13, I can put in 20, 21, 12, and 13, or 20, 21, 30, and 13, whatever you want to use. Then we are going to describe the outcome, and we are going to look at how that is different than the original program and take a screen capture. So when I do that, so let's say I put 31, 32, and maybe 30 here, right? And I want it not in order, so that way we wanted to see if this actually, it should, right? It should sort it and reverse it for me. And then it will start doing the permutation. So let's run this, right? So it's sorted for me. It gives me 32 first, even though I put it in the second. And then it gives me 30, 31, 30, and 4. And then it would then go through and it permutate, and it gives me the arrangement that would be less than the prior, and subsequently again and again until the end, which it's then give me 4, 30, 31, and 32 from low to high. So you see here that no matter what number that you put in your array here, what values, right? We would start it with the sort, reverse it, and then we can use the previous permutation. So that way, this function would take the order, right, which is the reverse sort, and then it would utilize that order based on the position of your element. It's going to compare, and that's how it compares. So we see how already next compare to previous permutation. Okay, so the outcome of number 2 would be the calculation for total number of permutation that we would have with the 4 elements. We would run the program and describe how the outcome of that program using previous permutation and how that compares to the number 1 example. Then take a screen capture. We would also replace the element values, describe the outcome when we replace the values, and how that compared to the original program, and provide another screen capture. And I had seen this being used in prior projects that were submitted by students, right? And you would see that there will be time that having a knowledge of these type of functions and how it used lexicograph would be helpful, right? You don't have to start from scratch and customize all your function. If you know how to use certain library and the functions in those libraries, it would be efficient. You would then just incorporate it in your program. Okay. Any question with 2? Okay, let me go back and put the values back. Then you have the next one, which is permutation. So this one's a little different than the prior. And we can use something like this to test whether the sequence of your term permutation is the same or not. So this will be good for comparison, right? Across 2 group of arrangements or permutated values. Okay, because it's using the equal operator. So It would return true if the first range is permutation of another, otherwise return false. So if there is, if it's the same in the arrangement, it's going to tell you that it's true. If it's not the same as arrangement, it's going to tell you that it's false. Okay. And this relates to what we talked about, how we would look at sets and so on. So the application for this would be that, let's say that you need to produce different combinations or arrangement of values and you want to compare the data, right? To see if it's matching. Then you can use is permutation. Let me see if I want to make sure that it is the same value. 053205 3 and 1. Okay, so let's take a look at example 3. This one uses the permutation function. And it's pretty short. So again, you are going to have C in, C out. So you would include IO stream. We are using algorithm STL, so we want to include algorithm. Then we want to have a main. So inside the main, we have 2 arrays. We have array A and array B, and each of those would have 4 elements in different order. Okay. And so we initialize array A with 1503 and array B with 0531. And after that, we would have a conditional statement, which is if else. We would say if it, and then we would use is permutation if array A and its element is the same as array B, that's what we're saying, is the same permutation as array B, output B is a permutation of A. Else, we're going to output B is not a permutation of A. Okay. So I'm going to run this. And it tells me that B is a permutation of A because all B is it's simply a rearrangement of A. Now, let's say that if I put 9 in here instead of 0, and that definitely it's not because 9 doesn't exist in the first array. And so when we arrange A, it would not match with B. Okay, so the way it looks at it is that the elements are the same in value. And this is a possible arrangement. But what if I do this? Exactly the same. It still is because it's a matching, right? So as you put that program into your IDE, you would run it. And you don't have to use those exact value. You can play with the values and so you can see the outcome. So the permutation, the possible number of arrangement for the permutation for array A, since it's again also 4 element, we would do a factorial of 4, which gives us 24 total number of arrangements for that array. And for B, because B is exactly the same value in just different order as different index, then it is a possible arrangement of A. So that's how it met true for this condition. So when after you run the program, take a screen capture, provide a description of the outcome. Why is it saying that it is a permutation of A? Then for C, we want to change up the element values for array B to be different. And then we want to run the program. As you saw, I did that earlier. So let's say we put a 9 here and maybe a 6 at the end, right? And so it's not going to meet true for this condition. It's not going to be true here. Then it's going to kick it over to else and it's going to output this. So again, from CIS5 and 17A, you know that if checks for true condition, and if it's true there, it will execute the body. If not, it's going to go to the else and it's going to execute the body of else. So for part C, we want to simply change up the value for array B to be different than A. Run it, take a screen capture, and provide the explanation of the outcome. Any question? No question? Okay. So some of the project cases you will be expected to know how to implement, right? The stuff that we learn. Oh, okay. Did it say that? Let me check. Sorry if I have a discrepancy there. Let me see. You have 5.
Oh, for example, 3.
Yeah, I'm looking right now. Oh, okay. Yeah. So, well, this is still 4. Oh, that's a misprint on my part. Thanks for letting me know. I need to fix that. Sometime I upload and I forget to change it. So, so for 3, if it's to answer that, so it asks you for 1 second. Yeah. So yeah, that's just a typo on my part. So for A, it's still going to be 24 because you only have 4 elements in array A here. Okay, so answer A is still 24. I'll fix it. I'll do that at the end. Other questions? Yeah, I know there's a typo for the other one, so I just highlight this so I remember. It should be 4 elements. If you want to do 5, 6, 20, it doesn't matter with me. I just want you to know how to be able to utilize this, right, for future references and understanding how permutation works. Okay, any other question before we do the last one?
Professor, for
Yeah.
the arguments and the condition, like in the if statement with the commas that are separating the elements, that just means compared to, correct?
No.
Okay. All right.
Yeah, so you want it to use the elements of array A, and then yeah, that it's going to compare the B. Now, if you don't have the B, then that's pointless to use the is, because is uses the equal operator.
I see.
Yeah.
Okay. All right. Cool. Thank you.
You're welcome. So when you read the information about the functions, it's also going to tell you what is required in the argument for all programming languages, right? It'll tell you the first part of the argument, what that does, the second part, what that does, and the third part, what that does. Some functions doesn't require a third option, but it would allow it, and some only requires 2 options. So in this one, we're able to use, right, 3 options in the argument, but because we want to operate the comparison, so we want to include which array or which objects that we want to pass as those arguments. All right, let's look at making our own permutation. So this one is a little different, and we are going to write a function to do permutation. So it's, a lot of it is comments anyway, and we are going to use rotate, and rotate is a function in Algorithm STL. Okay. So it says that rotate is a function that changes the order of the element in the range of first and last in such way that the element pointed by the middle becomes the new first element. So the middle is going to point to the first. And so basically it's swapping spaces, element index. That's what we're doing. Okay. And so that way we just changes the order, and we are going to use the middle to point to the new first. And that's what they call rotate. So let's open this up. So again, we are going to use algorithm because we're going to use rotate, and we are going to use IOStream. And on this one, I actually put using namespace std for those of you who like to use that. So we simply start with the declaration of your function. We're gonna define that. Okay. Now in this one, I didn't prototype it. Okay. So you you know, if you want to be fancy, you can prototype and then define below. But so here is our function. We are using void because you're not outputting anything there. You're not returning a certain value. Okay. So you are simply is just gonna use the string and then swap the characters. So you can name your function anything that would be pertaining to its job or its purpose. So we would say permute. And so here, what we want is we want to print the permutation for our string called str. And it is used to store the permutations one by one. So the string is just a container. str is a container of the arrangement of your characters. Okay. Then inside the function, we have an if statement. We would say if string size is 0, then we would say we would see out, and then return. Then we have a for loop. And in our for loop, we would have, and you know, for loop has 3 parts. The beginning, we're going to start with index 0 for the first character. We're going to finish at the end of that string size. So no matter how long it is, it's going to go until the end, and we're going to update one by one. So we're going to start with the first character, then go to the next character, and so on. Then for the next part here, what we're going to do is we're going to create a substring. So it's going to remove the first character from the string, and that will be putting into the substring, because that's going to be the first character is what's being pointed from the middle, right, as we rotate. So we want to rotate from the beginning of the string and then the middle, or the subsequent, which is the adjacent to it, and then the end. So it's going to rotate from the first and then the second, and it's going to keep going until the end of your string. Okay. So here is our function permute. Then in the main, we would then define our string, and we would use A, B, C, D, E, F. So that way it's easy for us to see how it rotates. And we are going to call on the function permute that we previously defined. And then we would pass str, because that's the storage, that's the container for our updated permutated string. And we would return 0. So when you run this, okay, you would see that it would go from the top, since we have what, 6 characters, 6 characters. So it's a little bit longer than the prior. Okay. Now, when you look at this, it starts with F, D, C, E, A, B, but when we declare it, we would go A, B, C, C, E, F, right? So it would use the middle and then point it to the first. So your last character, F, gets shifted to the front. And then we would have the subsequent. D, C, E, A, B, because then your AB is here. Okay. And then it rotates again. So you would have F, D, C, E, B. It swaps the A with the B. So you would have BA. And then it swaps again. So it's using the middle point to identify what would be the one that will be subsequent as well. So I want to show you this because it is possible to write a function for permutation. And we can capitalize on what already exists. So with rotate, it's rotating the string a way that the second character moves to the beginning. And we implemented that here. So how does it do that? Well, we in the argument, we have begin plus one, and then the end. Now, if I play with this, what if I start with the opposite, right? If I do F, can't see. And then I get the other way. So the front two right here, as you saw in the second round, it moves to the back. And then it takes the last, it puts that in the front. And then the C and the D, right, moves to the front. So the C was behind D, so then we would take the back, put it first, and then subsequently you got the C, the D, and the B is rotated in the middle. So when this gets put in the front, this becomes the middle. And that's what rotate does. And at the end of our permutation, we're the opposite, right? We are now, so if we start with descending order, we're going to end up with ascending at the end. But if we started with ascending order, we're going to start with descending at the end. Now, this one doesn't necessarily show you like the previous or the next, because in the other functions, the built-in functions, you would see that the subsequent arrangement are larger or smaller, right? But if you do the comparison, this one doesn't fall into any of those rules. It simply does the rotation. It takes the last, put it into the front first, and then it swaps the place for the two adjacent, and then it's going to put, so for the B, so the A goes in the front, the one next to it, it's going to be the middle, and then the two that's next to the middle is going to be moved to the front. So it's basically pushing that back and changing the index order. So put that program into your IDE. And if we have, I think I have 6 for this. Let me double check on yours, make sure it matches. Oh, 4 character. So I have 6 on mine, but yours might only have. So let's say I have ABC. T. That will be less. You would have 24.
Professor, what is the +1 doing again?
Yeah, so the begin is just gonna be the first index, index 0, +1 is the subsequent index.
Oh, okay. I got it.
Yeah.
Okay.
So if you look at A, B, C, D, right, we would start with A, B, C, D. It would go A, B, D, C because the C +1 is the D, right? Because it's behind C. And then the D now is in the middle. It's going to rotate. Okay. And when you play with higher characters, you're going to see it a little bit different. You saw earlier with the F. So if you use like an odd number of characters, you would see more obvious how it uses the middle. But when it's harder to see with an even character because then you don't see the obvious middle character. But it's always going to end up with the descending. If you start with ascending. If you start with descending, it's going to end up with the opposite. So 4 characters is going to be factorial of 4. That will be 24 again. If you use 6 character, it will be factorial of 6, like what you saw earlier, so it's longer. Run the program, give me a screen capture, describe the permutation output compared to example 1. It looks like it, but it's not, right? Because if you look at the output, it's close. Okay, so there are some that would show that, yeah, it is larger, and so on, and eventually it will be higher in the order. But if you play with the longer string, you would see that some of the iteration, it doesn't necessarily is not higher than the previous as the arrangement. Like the arrangement in the subsequent, some are low and some are higher. So the similarity between this example and the first example in that you do have the opposite as the outcome. If you start with ascending, you would get descending at the end, right? In the first one, we started with ascending period, and then we ended with descending. The different in that we can start with the descending and it would give us the ascending, which is similar to number 2. So this one works for both, but it doesn't give you larger or smaller arrangement necessarily. Sometimes mostly large, but not always the case. It's using rotation instead. So for C, so after you run the program, give the screen capture and provide the description of the output, you can do C in that you would use 6 characters. So let's say we would do EF. And so you can see more. Okay. Describe the output for the 6 characters. How many arrangements do you expect for 6 characters? That will be factorial of 6. And then if you want, you can put that into your calculator, right? Use the scientific, take 6, and then factorial of that. So you have 720. So your output, you have to scroll up to kind of see all the arrangements, but there you go. Any question? And then if you increase that, right, you have more. And then you can look at all the arrangements you can see. But at the end, I have the opposite of what I started. Okay. So the takeaway from this is that you can write your own permutation algorithm, right? You can use existing functions in libraries to be able to give you outcome for permutation. Depending on the type of permutation, you would choose the appropriate functions. And you would see that the outcome would be slightly different compared to what when you look at like next permutation, previous permutation, and is, and also customize your own permutation. And this is not the only way that we would do permutation, of course, but that's one way. So you can always come up with another way. And in this one, we simply use rotate. That's why we have to include algorithm. But you can, if you don't want to use rotate, if you wanted to switch a certain way, then you would be able, maybe you can implement a loop to be able to do that on how it would swap, right? Index or if you want to implement a pointer on which character that you would always point to. But your goal in permutation program is that you have to make sure that it permutate and give you the total number of arrangement as intended. Okay. And order does matter when we look at permutation. Any question? Oh, so early today. Huh? I'm going to stop recording.